morning, everyone. Welcome to the Open Source for Digital Autonomy session. As you can see, we have great speaker with us today, and thank you for joining this session. Please also join the conversation by asking questions in the live discussion section on this page. Luis, I think maybe we can start.
Okay, then let's start. I hope you can all see the presentation. My name is Luis Busquets, and I work in the Cloud and Software unit. Indeed, in our unit, are very interested in what is open source, and also we have seen how open source views and usage of open source has changed quite a lot in the latest 20 years. Actually, that was when my interest in open source started. Indeed, open source is much older. We can get it back to the 90s, but what is true is that it was in the first decade of this century, when it had started to have interest. Note that we are not interested as European Commission in open source per se. Actually, the objective of a public administration is always the citizen. And indeed, the EU citizen is at the center of the European Commission interest. And the EU citizen is at the center because we want to give more freedom, more possibilities, less constraints to all European citizens so that they have more possibilities to deploy. And that actually goes with the economic growth and encompassing better jobs and better possibilities for all European citizens, also including a better environment, such as what we are trying to do with the Green Deal. In Unit E2, we are dealing with a particular part in order to provide this better economy and better possibilities to the citizens, and this part concerns cloud and software. And it concerns cloud and software because software is a key digital technology. Actually, in the end, we have always the EU citizen, the consumer, that is actually wanting to have more services, more possibilities, and it has cloud providers supplying value-added services. But in order to supply these value-added services up from the raw material and the raw economy, we do need a certain number of steps that increase value in the actual devices that are done. Well, in order to supply cloud services, you will need someone who's got an actual infrastructure prepared for it. And in order to have an infrastructure, you'll need a system integrator building that infrastructure, who will need to actually purchase from providers, from server vendors, which need components on silicon manufacturers, which actually that goes back to the clouds, to the actual raw material. And indeed, in the cloud unit, we're also very interested in software, we're the cloud and software unit, because software is a key technology in order to supply cloud services. And as that, we are also interested in open source. We have seen how open source has built a complete stack. From the kernel up to the application level. And in some cases, you could just rely on software, which is open source, for supplying specific services. What is also true is that below the kernel level, there are still places which are closed. And what is also true is that the technology has changed a lot in the last 20 years. And what was before implemented in hardware, now we're implementing in software. The capacity of digital processors to execute instructions mean that we no longer have to define in analogic Butterworth filter, but actually we program it in digital and we have it. And that's the reason why software is becoming more and more important, and also the interest of my unit is specifically in open source. But let's be clear, open source today is now far more than just software. Open source is spreading through other domains. We're seeing the advent of open source hardware, either when we speak about the new processing architectures with RISC-V, but also open source electronics, even 3D printer. 3D printing allows you from a source code to build a specific part. So indeed, we are seeing how open source philosophy is spreading in other sectors which are not just software. And we can also speak about open science as I don't know if the older brother or the big implementation of what is open source software for the whole science and not just the IT sector. And indeed, the open source vision has also been changing quite a lot in the last 30 years. At the beginning of the century, we were thinking and speaking a lot about procuring open source software and how it removed vendor locked in, and what were the benefits of public policies in supporting and also using open source. But this was 20 years ago, and actually we have even gone a step further. It's not that this is not important, of course it is, but now we regard open source as a public good, a common good on which we can build things, and well, as it is free, we can actually build our own enterprise, our own company, develop our product using open source assets which are already there, and therefore allow us to outsource part of our costs to things that are already available to us. And from a public perspective, our interest in open source goes with the question on how can we actually make open source to maximize its return in the European economy. And what it becomes clear is that in order to maximize its return, we require policies at EU level. And when we speak about open source now, we start thinking about open source for what? What can be usable at European level? And the question is very easy. We're speaking about digital autonomy. Digital autonomy doesn't mean that Europe is going to be isolated, by no means. We want to have strategic autonomy. Digital autonomy is about defending European strategic interests, being assertive of what are the European values and firm in the European ambitions, and also confident in that Europe has the means, if it needs, even to go alone, even if it is not the thing that is wanted, but actually having the possibility of going is what we do want, to be able to know that we have the ability to act independent if there was a case when it was needed. And open source, actually, it's not only a tool for digital autonomy, but actually it's also impacting the industry. No matter that we don't do anything at public administration level, well, actually open source is here and is here to stay. And open source software and hardware are having a footprint in the economy. And it was because of that reason that we launched a study on the analysis of the current role, position and potential in the European economy. And also we investigated and quantified what was this economic impact. Of course, the level of maturity of open source software and hardware are different. If we now see that open source software is mainstream and everybody is taking steps in the ICT sector to use it, or at least to put it in its strategy on how to take care of it, for open source hardware, we can see that it's in an emerging phase. But anyway, the Commission is already taking steps on what open source is doing. And actually, we're having lots of projects in the open source domain. The Next Generation Internet initiative is also taking a long number of open source hardware and software projects. And in my unit specifically, we are very confident in the use of open source for cloud-based services. And well, I would like just to draw your attention to the call that my head of unit has already presented at the beginning of this workshop that is opening on the 23rd of November, and which concerns to build the required interfaces that are still missing to interface with flagship projects such as the European Processor Initiative and cloud services. So what are the things that are still needed in order to make sure that we can integrate the EPI results in a data center? And probably that could be a big link with open source distributions that take into account new processing architectures. It could also probably mean the development of some missing open electronic interfaces. And it could perfectly mean to develop the basic input-output system of this open electronics. Well, of course, based on really common really common standards in the industry for interfacing with other devices, and also on the basis of specific standards developed at the EPI for the interconnection with the CPU. But it's not only this that we are doing at European level with open source. Actually, we have launched an open source strategy for our internal needs and for the management of our internal resources. And in this sense, I would like to give now the floor to Miguel Diaz Blanco, who is my colleague dealing with the open source implementation in the Directorate General for Information Technologies. So, Miguel, you want to take from here?
Yeah, sure. Thanks, Luis. I will share my slides and let me know if they can see properly, because before it was too small, so there was a comment that maybe that was too small. Let me see. I cannot see the chat, so let me know if you can see them more or less okay.
It's perfect like this. Thank you.
Okay, thank you. Okay, yes, hello everyone. My name is Miguel Diaz. I'm the project lead of the Open Source Program Office in European Commission, and I will give an overview indeed about the open source strategy that was released last year, and then I will go more into concrete things that we are doing as part of the strategy. I always start like that. I like to start like that, saying that in my directorate in Digit, open source is not something new to us. It's something that we already been using since 20 years ago. We have been gaining maturity every year. We are using more tools, we have more knowledge. And during this journey, we have had several strategies, but these strategies, they had a local scope. Let's say it was a strategy for Digit, for my Directorate of Informatics. It was not something for the entire institution. However, the European Commission strategy that was released last year is different, and I like this final box that you see, which means transform, because at the end of the day, this is what we are trying to do. And we like this motto that comes with the strategy, which is think open, right? Which is try to think a bit other ways of doing the same thing. This strategy was published in October in 2020, and if I could say three things about this strategy, the first one would be, as I mentioned, that it impacts the entire organization. So it's a strategy for the whole commission. We all follow the strategy given by this document, not only Digit as it was before. And what makes it very interesting, and it's something that Luis before, is that we make the link between open source and our policy goals at commission level. So we want to promote competition, we want to encourage SMEs, we want to achieve digital sovereignty or digital autonomy. We do believe that in those aspects, open source plays a very important role, and that's something we try to reflect in this strategy, source as an enabler for those policy goals. And finally, something that is characteristic of this strategy is that it comes with an open source program office, which is the team that I'm leading, and where we basically change the working culture of Commission, following open source principles and practices. If you want to know more, I don't know if the slides will be shared, but if you want to know more, there is a link at the bottom where you can see the document and in its totality. The action plan, the strategy source comes with an action plan. There are 10 actions that come with this document. And in the next slides, I will go through some of them, not all because we don't have time, but I will try to give you an overview of what we are doing under this action plan. The first one, it's something that we already did last year, the creation of an OSPO, an open source program office. This is something that more and more many organizations are starting to implement, both private and public. And as I said, the fact of body nows give us the legitimacy, let's say, to take care of some of the actions that come with this strategy that you will see in the next slides. Action 2 is something either source as default. And I like this picture because it's about breaking silos. You have to understand that Commission is a huge organization. Only officials, I think we are more than 30,000, and we produce a lot of code. We have 1,000 projects, and it's a pity that in our software repository, sometimes this code is not visible to other teams. So what we are trying, and we have done already, is to that every time we have a new project, by default, the code will be visible to other teams, so that we don't risk to have different teams doing the same thing or similar things, or teams not benefiting from what other teams are doing. So from now on, every new project that is created in Commission, by default, the code, the documentation, the tickets, they are visible to other teams in Commission. And we are applying this retrospectively as well. We are looking now at projects that maybe were launched 1 year ago or 2 years ago, and we are asking them whether it would be possible to make it public, because at the end of the day, we all benefit. We save money and, and we reduce knowledge. And why not to even to contribute? This would be something we would like to see in the next years, to see even pull requests between these projects. A third action, action 3, it's about our presence in the open source arena. Let's say we know that other institutions like NASA or the European Space Agency, they are present in app. And as mentioned before, we have a lot of open source projects, but we are all following a little bit our own way. Some of them are in GitHub, others are in GitLab, others just publish the code in a website or on an FTP server. So we want to have a structured presence when we publish our open source projects. And now we are working on this external repository, so that, okay, we can concentrate all our open source projects, and people from the outside world, they can contribute to these projects. Action 4, it's also in this aspect of changing the organization. Today, in Commission, if you want to go open source, you need to do some paperwork, and it can be very heavy sometimes. You need to write these kind of documents that are called Commission decision. You need to review it with your management. You need to get the approval. Called inter-service consultation. So it's discouraging sometimes when you want to go open source to do all this when you are not for that kind of job. So we have done already Commission decision, which is the kind of documents we use for that, to eliminate all this paperwork, so that if project team they want to go open source, they can go without having to go through all this paperwork. Still, there will be a check to be done, which is the intellectual property, to make sure that if we go open source, we are using the right libraries. So that check will be done still, but all this paperwork or administrative job will be not needed anymore. And something I would like to add here as well is that with this decision that we are getting approved in the next weeks, we will also allow to have some extra time during the week for developers to contribute to open source projects, as long as it's not a big amount of time, but to have at least the freedom to contribute to the open source community as well. Another action that we are running as part of the strategy, as part of the OSPO, is we have the open source labs. We have a space in the cloud where teams can use that space to test open source products that we believe Commission would benefit from. So we are open always to proposals, and we give them this space that we are financing, and they have the chance, the opportunity to test. And ultimately, we would even propose the inclusion of these open source solutions to senior management, to our directors. Say, look, this specific product, we believe there is a use case for that, or a business case, even if you want to call it. Please, let's include it in our, let's say, app store or in our portfolio. So again, this is in the spirit of promoting open source products within Commission. Something that we do as well as part of the strategy is to outreach to open source communities. We during the whole year, we have been running bug bounties, so having ethical hackers trying to find vulnerabilities in open source products. So we financed bug bounties for this year for Moodle, which is used in the educational environment, Element, the messaging solution, and Simbra, which is an open source client. So we finance these bug bounties to help these open source communities and make them more secure and reliable. We have been done also 2 hackathons, one about Jitsi, the open source video conferencing tool, to make it to enrich it with additional features. Also, we did a second one with Xroad, which is the interoperability solution used by the Nordics, but to make it more able to understand with our interoperability solution, which is called eDelivery. And finally, we have done studies. We are about to close 2 studies. One, it's about a study about the feasibility of a funding mechanism for open source. Does it make sense to have a European open source foundation to finance open source projects? We are seeing the results very soon. And then an inventory of critical open source solutions used by public administrations in Europe. We are very interested in that study as well, because we want to know what other critical open source is being used in Europe so that we can help them as well, again, with more bug bounties maybe, or hackathons, or maybe other means. And the last action I wanted to talk today about is Action 8, which is about talking to the IT governance teams. As you know, in many organizations, you have the IT portfolio management. So you have the projects that are being assessed and evaluated. And we talk to them to make sure that when they assess new projects, new business cases, take into account the open. Are you using open source technologies in your project? Are you planning to go open source once your project is implemented? These kind of questions. And we hope that little by little, by again changing the culture, right? That when we assess projects, we always have this think open, these aspects in mind when we produce software. So this is in a nutshell what I wanted to present, because I didn't have that much time, but I hope that I gave you an overview of the things we are doing at Commission. And I pass the floor over to you, Luis, or I don't know.
But, thank you. Thank you, Miguel. And now I will just get it. It's here. Okay, so what are the objectives of this session? We want to validate first the importance of open source for digital autonomy, and also to identify specific fields in computing architectures that are still requiring for open alternatives. We will also like to define which are the priorities for support in open source development, and basically to obtain input from all of you. The Commission is not working in an ivory tower. On the contrary, the Commission is building its work programs on the basis of what you are saying and what you're teaching us. And therefore, the first speaker will be John Davis. John is the director of the Laboratory for open computing architecture at the Barcelona Supercomputing Center. He has published more than 30 referred conference and journal papers, also has over 30 issued patents in distributed computing and bioinformatics, and he is the chair of the RISC-V special interest group in high performance computing. And so the question to you, John, is clear. What are the missing parts that you think that we should develop in open source in order to make sure that what is being developed for the new processing architectures in supercomputing are then implementable and usable in cloud data centers? So, John, if you want to take over.
Thank you, Luis. Let me share my screen, if I can figure out. Share screen. All right, so I'm coming from a slightly different perspective in terms of it is focused on high performance computing, but I wanted to talk about the space in between. And so when we talk about high performance computing or open source, there's a lot of interesting things going on. So first, let me give you some background in the context of what's going on there, right? So today's tech, we see massive penetration on the open source side, which we've been talking about today, and it's ubiquitous. It's from IoT to high performance computing and everything in between, whether it's using Linux for your operating system or as a basis for a bunch of other components. We're seeing a lot of penetration there, which is great. On the hardware side, we're looking at a slowdown of Moore's law, and that combined with power constraints is really forcing us into an area where we want to build specialized hardware. It is more cost effective. It provides the performance that we need in the power budget that we're looking for. And so this is really bringing this opportunity to do software and hardware co-design. And when we talk about open source software, we have the access to the code, so we can actually do the software part. So that's what I'm highlighting here. And really what we're looking at for the future is how do we do that in the hardware context? And that's where this is an exciting time to be, in a place where we have a bunch of different alternatives on the open source hardware that are becoming more independent, more mature, but there's still a lot of work to do. So we're looking at a lot of things in RISC-V and how to make that feasible in terms of architecture definitions for high performance computing. There's also open power, and these two give us a lot of different capabilities just in general. Now, we also want to take a look today, right? So when I talk about the stack, we have all these different components in the layer, in the software side, starting from Linux and moving its way up to applications like GROMACS and everything in between. There is some work in the Open Compute Platform, or OCP, to make some of the hardware platforms open source, but there's still. And then when we get into the CPUs, GPUs, and other ASICs, those are generally proprietary or based on proprietary ISAs. And so this is where we want to change the future and making high performance computing completely open. So how do we get there, right? So the challenge is on the software side. And so what I'm showing here is just kind of a graphic cartoon of when we look at open source, a majority of it's made for x86 today in the context of high performance computing servers and PCs. There's ARM is bringing up is becoming more involved in this space, but it still has a long way to go. But the nice thing is you can look at time. If you add more time, ARM and the ecosystem can compile those codes and optimize them for that space. And RISC-V is just starting out. So there's an effort that can be done there, but we have a larger community that is interested, invested in making that happen. So we have this interesting trade-off of time and people, and open source gives us that opportunity to leverage people to reduce the timeline. So that's kind of the fun part. So what that means is with things like RISC-V, we'll be able to get to a place where we can use that as a unifying language and design construct to create CPUs, GPUs, and ASICs that give us the capability the software and hardware co-design. And this open source capability gives us a non-proprietary framework that we can then from EU solutions. And so that's really the fun and exciting part there. And there's a lot of momentum. We're seeing it first starting in the embedded and IoT space, and the special interest group for high performance computing is adding that on top and starting from the top and working down. So we're kind of going from both sides, which is kind of fun. A fun place for this in general. Now, but what do we mean when we talk about that, right? So I wanted to highlight all the other pieces, right? So the nice thing here is we have standard interfaces in black. They can be AXI, they can be pipe, DFI, all these different things. And when we talk about RISC-V, really we're talking about the things here in green, the RISC-V cores. Really, there's all the other components in the system on chip. It could be the network on chip, it can be the on-chip memories, performance monitoring, power, all these other components that need to be developed to actually create your RISC-V chip, your package, and all those things. So when we talk about the ISA, that's really focused on a very small piece, and there's all the pieces around that to then make it into your accelerator or your general purpose processor or what have you. So these things are, how do we create the ecosystem on the hardware side at the base level of the chip to then build those out, whereas the cores are one of those pieces. When we look at RISC-V today, there's over 100 different cores you can use. Some of them you pay for, some of them are free, but the pieces around that are actually essential to actually build something that can be usable in a system today. So that's kind of the interesting point there. Now, there's also the software in between. So we have the hardware. What do we do? Power on reset. What do we do for the bootloader? How do we create the BIOS? Other types of things that build that before we even get to the operating system. So these are kind of the spaces in between that we need to fill out to make sure that they are functional and support the overall ecosystem. There are things like Core Boot and a few other things that are coming online, but those need much more support and overall a stronger drive to create a fully featured ecosystem. And so this is really where, if we look at all of the other components, I wanted to focus on that space between both on the hardware and the software side to make these things, get them to be mainline, right? And that's the big overall challenge when we talk about open source in the full system stack. I want to keep it brief, and hopefully this gives you guys a sense for where we fit in the ecosystem and how that works.
Thank you very much for your input, John. Our next speaker will be Leire Oruechevarria, who is a Cloud Continuum Project Director in Tecnalia. And as system integrator, my question is, to what extent open source can provide you with digital autonomy to not be locked in particular manufacturers when supplying products to your customers? So Leire, the floor is yours.
So can you see my screen and can you hear me?
Yes,
okay.
We can hear you.
Okay, so I have structured my presentation in two topics, I would say. One is open source and the other topic is digital autonomy. I will be very brief because I would like to foster more discussion, I would say, between the different panelists, if possible. So the first topic is open source and how we use open source in Tecnalia. So in Tecnalia, we develop R&D projects, but we also develop commercial projects. And open source helps us speed up the development processes. So we take open source libraries and open source software out there, and we use it to set up our own components, and this allows us to focus on the scientific and the research results, so do the innovation that we are supposed to do, and focus on the important aspects. That's what our customers expect us to do, and for instance, what the Commission expects us to do when we do Horizon 2020 projects. In return, most of the results that we release are also released as open source. Our challenge comes into how we exploit these results, how we bring these results in the market or to the market, and usually that's as part of auxiliary services, but also as transfer through the transfer technology office. I also heard the presentation by Miguel, and we also follow a very similar strategy within Technalia. So we also have a GitLab repository that we also offer to other project partners. For instance, in Horizon 2020 projects, but also internally in Technalia, we can see the code from other people, and we share the code in there. It's called gitcodetechnalia.com. And we share the code in there, and you can see all the repositories. You can see the code in different languages. We also have our own Docker registry, so you can also share the Dockers, Artifactories, all the binaries. We have a channel in Teams, so we can also share all the practices. So we have all the different best practices possibilities in there. So that also inside, so in-house, we are also sharing all these open source, I would say, best practices. Which are the challenges in open source besides the business model, or how to decide which are the licenses that we should have for our own results, and how to exploit the software that we develop? And this is more for, say, the creation of an open source repository where the results from, in this case, Horizon Europe projects or Horizon 2020 projects can be indexed or can be deposited. But here comes the challenge of also ensuring the governance of this kind of repositories, of this open source code, also the compliance and the security, so that no vulnerabilities are inserted, the quality of the code, and so on. This is similar to the open science concept, I would say, or similar also to Zenodo concept or something like this. This is how I would envision it. My second part of the presentation is more related to the digital autonomy. So when we were trying to set up our own cloud laboratory for experiments, we did have some challenges, not only in the hardware, there's a monopoly, that's clear, but also in the virtualization software. Of course, there were alternatives, but we saw ourselves just going for one specific alternative because it was the, let's say, the one that offered us the best possibility, I would say. So in the end, we were highly dependent on one or two solutions because it was the one that offered us more interoperability and more support and yeah, more capabilities, I would say. This brings us to the next question, and it's that in order for Europe to be autonomic in terms of digital technologies, we cannot develop these technologies in isolation. So we need to do this in combination. So cloud has to be done in combination with, or has to combine with artificial intelligence. And we had the first example today with the cognitive cloud session, for instance. Data is also very important. And then we have the IoT, so security. So we have this challenge with all that encompasses that. And I didn't want to go into the details because of the previous session. And also something that was also mentioned in the previous session this morning, in the opening session, that the solutions shall cover many domains, and they have to be cross-domain, but also with the verticalization. There are some parts that need to be tailored to the verticals. Which are the challenges? There has to be some open standards. Also within the work programs and the topics, there has to be some room for the interdisciplinarity. I mean, now it is clear that the topics need to be more interdisciplinary than ever. As we've seen, there is no one there's no one specialization in anything. There's multiple specializations, and still we need to, as mentioned, also we need to stick to the European values, and that can be done through regulations. So this is how I envision the open source for the digital autonomy in Europe. So thank you, Luis, for the invitation.
Thank you very much, Leire, for your contribution. Our next speaker will be Mirko Boehm. Mirko is the head of delivery at Envision, which is part of the Mercedes-Benz Group, and also founder of Endocode. And what's more important, he is also a contributor for the cool desktop environment, which certainly many of us have to thank him for having done, as we can run our computers with it. And the question to you actually is clear. As user, contributor, and also as part of the automotive sector, which is one of the most important industrial sectors in Europe, what do you think that are the key challenges and issues that can help the European economy to become more competitive, and specifically the automotive sector? So Mirko, the floor is yours.
Okay, thank you. I hope you can hear me and see my screen. Okay. So I also try to keep it very short and bring in the perspective of somebody, as Luis said, who comes from the open source software sector and now watches with amazement how it spreads to hardware and basically the whole stack. It is also great to see in the previous presentations and in the opening presentation how many of the recommendations that have been made in the last couple of, let's say, 2-3 years maybe, are actually being implemented by the European Commission, kind of also underlining what you said about not living in an ivory tower and be connected to the real world. I think this is really great progress that we're seeing here. I brought 3 topics today, trying to fit this all into 10 minutes. First, I would like to elaborate a little bit on the interaction or relationship between autonomy and open source. We also had a discussion on the digital sovereignty, and from a pure software perspective, autonomy and open source are basically one-to-one matches. The licensing of open source software as such provides all the necessary needs, all necessary tools to be autonomous in your decision, how to use the software, for what purpose, how to continue to develop it, etc. However, that only covers software. And if we are building real-life products or services, then that's not all you need. So essentially, when you take the software and you build products or services with it, you're creating principal-agent problems. And I've highlighted 3 here that I think have emerged as essential ones. When you're operating services, the principal-agent problem is that the customer using the service has to trust the provider that they're using the software that they promised to use in this case, or that basically there's a level of trust involved that says, I operate on your service and I trust that you're not spying on me, for example, or you're abusing my data. This is a general problem when we're talking about managing other people's data. And coming from a perspective of the automotive industry, we are building large computers on wheels. Some of them look very slick, but they're still embedded devices. And we're also operating cloud services. So all of these issues are highly relevant for us, and we are massively depending on the trust and basically the trust that our consumers put into the products that we're building. So we are managing their data, and that creates a second principal agent problem, which is with data, it's not just a question of where to store it, but also where does it get to, who else gets access to it, etc. So, and since copying data, it doesn't reduce it in quality, it's very difficult to provide surveillance here. And the third principal agent problem that I would like to highlight is that of the provider of silicon. I think in the software industry, there is a pretty strong confidence that if I instruct the computer to do something, it does what I tell it to do. That is true for the layers of the software stack that I'm actually controlling this way. But we see that computers they are doing things under the hood that we don't see. We had the Minix operating system mini scandal, where we realized that computers below the operating system that we install or next to it use another operating system to provide remote management services. And since any program can be executed by that, it's difficult to enable trust if you have the feeling that under the hood, the machine does other things and it's being instructed. These are examples of principal agent problems in the open source software and hardware spectrum. I'm pretty sure these are not the only ones, but I think these are relevant and highly important ones. And when we refer to open source, essentially it's a licensing model. We're saying by providing certain freedoms to the users of the software through the application of a license, we create an openness and a transparency that solves some of the issues that I speak about. Trust, you can enable collaboration this way, you can enable reuse and the creation of derivative works. But you can't solve all these problems. So software licensing is not a panacea that solves all the problems that I talked about. So the essential question, I think, is how can these remaining gaps that I try to highlight can close to attain autonomy in the digital society? I don't have answers to all these questions. I think that a lot of the answers lie in regulation and in audits and contracts, so not in technical solutions. So technical solutions can support, but we will have to explore these other two venues, basically agreements in private relationships, maybe enforced through audits, and regulation to really get there. Open source technologies, both software and hardware, is this kind of rising tide that raises all boats. And this is an interesting aspect when it comes to autonomy, because we see great technological advances. We see them in chip design. We heard RISC-V managed earlier. That's one of my favorite projects of recent years, because it's really changing the market. So chip design is increasingly open. And this has, in a way, re-enabled competition in a market that was very rigid. However, the expertise in how to design chips and how to produce them is increasingly specialized. It is very rare. And it's not widely spread, because experts that can do this, they naturally flock to where the industry is. And we have very few clusters in the world where the industry is actually located. And that means transporting expertise about how, for example, a chip manufacturer could produce chips in Europe depends a lot on the ability to get the expertise on the ground. And then the third aspect here is, of course, production capacity, which is also increasingly somewhere else. And this together creates a problem where we are looking to open source, which provides us the access to the technology and the freedom to use it and the freedom to further develop it. But open source only contributes to the autonomy, because autonomy means being able to make the decisions that we think are best for us. And this ability to make decisions is not limited necessarily only by the access to the technology, but also by the other factors that I've highlighted here. And finally, to kind of put the role of open source into perspective here, I really think that it is closer to standardization than it is to, for example, a tool for autonomy as such, right? We've worked on this a lot and tried to explain how open source provides an alternative mechanism to reach standardization in markets. The role of standardization here is really important because it's essentially a market builder, right? By agreeing on technology, we're shifting the competition to the products in the market, as opposed to like kind of conquering the market or building it. And this is an enabler for the competition that we would like to see and for the innovation that we are requiring to maintain and gain autonomy. And open source is such an enabler. I think that is very important. But basically, to summarize what I said, there are cases where it doesn't solve all the needs, as I've highlighted, and there are cases where the market does not by itself provide the solutions that are required. I think there are at least two situations here that can happen. One is a general lack of incentives. If a problem is solved, say, on the computer and is available for a cheap price in the market, there's a very little incentive to replace it just for it to be open or based on open source or for transparency. So there's simply no benefit to be gained from redoing this in a different way. So the first case here would be simply a lack of incentives, a lack of impetus to change anything. The second one is if openness, transparency, and then autonomy actively conflict with market differentiation. So for example, if a manufacturer actively has no interest whatsoever to publish technology because that's how they control the market. And in this case, this of course asks for regulatory intervention to re-enable competition in such cases, or to provide technology by, for example, enforcing standards to remove such barriers. And we see such conflicts in market differentiation, but also in security, when sometimes there's an argument that things shouldn't be open because then people can see the security issues in there, or in privacy, or sometimes also in trade secrets, but I didn't highlight that here. So I wanted to highlight this, the role of open source, how it can contribute to autonomy, digital autonomy, and where the limitations are and where other instruments are needed. But I think I try to also highlight how the different instruments that we can apply, especially private contracts and regulation in combination with open licensing, can contribute to a strong digital autonomy in the European market. Thank you.
Thank you, Mirko. Indeed, it's a very strong message. Openness guarantees access, but only contributes to autonomy. And certainly we will have to work on this. Our next speaker is Knut Blind. Knut is the coordinator of the Business Unit Regulation and Innovation at the Fraunhofer Institute. And he is also the co-author of the study on the economic impact of open source hardware and software in the European economy. And so the question for you, it's also obvious. To what extent open source is impacting, and what are the main measures that you would support if you would have only limited resources in order to maximize the economic impact of open source software and hardware? Knut, the floor is yours.
Yeah, thank you, Luis. You see my screen?
Yes, we do.
Okay, thank you. Yeah, not much time, therefore I will be also quite brief and focus on maybe only a few things. First of all, as Luis already mentioned, we did this great study for the Commission, and it was also an honor to do it. And regarding the economic impact, and we came up with numbers between 60 billions to 100 billions per year, which is for the EU economy, which is really quite a lot. And if we compare that to the investments, we have cost-benefit ratios 4:1 or even 5:1. That means it really makes sense to invest also from the public perspective to invest in the support of open source. And based on this general kind of justification for the European Commission, but also the national governments to invest in open source, we came up with a few policy recommendations, and I focus on just on a few. because it was also the whole event is a little bit about shaping future research program within Horizon Europe. And therefore I focus a little bit on those policy recommendations which address these R&D funding dimensions. However, maybe in the discussion we can also a little bit go beyond, because in order to assure or regain digital autonomy, there might be also other instruments also shaping maybe or reshaping the regulatory environment in competition policies. Also public procurement might be some keywords to go back when we discuss it. But I focus on four areas of policies which are more or less kind of the baseline or the base for really pushing then at the end the economic impact, because we have seen the more contributions the better it is for the economy. And some strategies or even programs and concrete actions have already been named by Luis and his colleagues. But I think it definitely makes sense, and therefore we appreciate that maybe the upcoming calls in Horizon Europe are focusing more explicit on open source than it has been done in the past in Horizon 2020 and previous. Therefore, this is certainly justified by really the positive impacts of open source for the whole economy. And what we also found in our study is that especially SMEs and even micro companies and startups are really strong contributors to open source, and therefore for them it should be really easily the access to these programs should be quite really facilitated and easily possible, because they are at the end from a European perspective, which is a little bit different than to the US structure, where the big players are heavy contributors, but in Europe are the small ones. That's first issue. Then regarding knowledge diffusion networking, here we also should push some activities. It has already been named that and mentioned that the administrative burden to really make the results of publicly and also European Commission funded R&D projects and code open source have been reduced, and maybe on the other hand one could even provide active incentives to do so. The other idea, maybe we can discuss that there are open source repositories which are located in US and especially related to the objective of digital autonomy. Maybe the creation of such repositories within Europe could be an idea to strengthen also then the distribution of the open source within Europe and achieving or securing digital autonomy. Very important is the entrepreneurial dimension of open source, because we have, as I already mentioned, seen that especially really micro companies, very young companies, are heavy contributors, and therefore we have to also educate and maybe establish a culture to push and promote open source based startups. And here it's not only about really having kind of very good code, very good developers, it's also about developing sustainable business models. And here maybe also trusted intermediaries, and here especially we think maybe about the open source foundations, and for example Eclipse move to Europe, which might be another also anchor and opportunity to foster digital autonomy within Europe. And maybe this is in the long run the most crucial aspect, human capital. The recent survey by Bitkom on what are the problems related the contributions of German companies to open source highlighted again that there's definitely a lack of skilled people who can do that. We in Europe have, in addition, kind of a demographic disadvantage against especially Asian countries, and this has to be tackled, because that's more or less the starting point. Therefore, also universities, higher education institutions should really push more the topic of open source within their curricula. And it's not only about the software development, it's, as I said before, business model based on open source. Also, the quite complex licensing issue is also a kind of material that should go into the curricula. And also entrepreneurial management skills should be provided, which allows then micro companies and SMEs to grow. What we see not only here but also in other contexts is the growth of really successful companies is much kind of faster and more significant in US than we see that in Europe. There are not so many. We might also think about maybe a certification scheme. Good certification always goes with cost, but in order to reduce the information asymmetry in the labor market, maybe such a scheme could be an instrument to increase the efficiency in the market. And a final issue here, diversity. The open source contributing community is not really very diverse. Also, a recent study by the Linux Foundation in the US showed that here maybe diversity is also maybe an approach to address the shortage and probably increasing shortage of human capital which Europe is going to face. It means overall there is a big economic impact of open source for the EU, and maybe also in the future an increasing impact of open source hardware. And therefore we need public policy. It's justified because of these maybe 4-to-1 or 5-to-1 cost-benefit ratios, in order to incentivize the further contributions, which is at the end benefiting the European economy, the European startup scene. Figures show, or our calculations show that here, if we really contribute significantly in the future, then we can expect maybe 600 to 1,000 additional startups in the IT field, which base their business model on open source. But in order to get there, we need really a very comprehensive policy approach, and also a very coordinated policy approaches. It's not only about R&D funding, it's also really providing or maybe adjusting the regulatory framework according to the needs of the open source communities. And also quite nicely, Frank Nagel kind of compared or assessed our suggestions, and he came to the conclusion that almost all of our policy recommendations are also could be also addressed to the US administration. Therefore, we are quite sure that at least we touched the right topics, and now it's up to the policymakers to implement and realize at least some of our proposals. Thank you
very much, Knut, for your contribution and also for the delivery of this study, which is a milestone, I would say, in the history of open source, and in the same level, at least, of the study of 2007 of Rashid Ghosh. And certainly, it represents an advancement in our understanding of open source in the ICT economy. Our next speaker will be Joseph Urban. Joseph is the Nokia CTO partner and deals with corporate activities in the area of security and software. But also, Joseph is the chairman of NESI, which stands for the Network of European Software and Services Initiative, and it's the European technology platform dedicated to software, services, and data. And in this context, I would like to ask Joseph about the views of the different partners at NESI concerning open source possibilities for the European economy. Joseph, the floor is yours.
Thank you, Luis, and good afternoon to all who are online here. I just try to share the I still have some problems, so maybe do I have right to share?
Yes, you should all have the right to share. So
No, my button does not allow to do that.
okay, in this case, I think I could share them from the copy you sent yesterday.
Yeah.
Okay, so let's see.
Can you see it now?
I can see, yeah, now it's coming. Perfect. Or if you go in presentation mode.
Now it's twice. I will stop sharing mine so that it's only Valentin. Okay, so Valentin, now you're the one in the screen.
Yes.
So thanks again, Luis, and good afternoon. And sorry for this short delay. Let's see whether it's still possible to show it in the presentation mode. As already introduced by Luis, I will talk as in my role as chairman of the NESI board, and my talk will be based on position papers that NESI has published around 2 years ago. And in this position paper, we have discussed multiple facets and the different views on open source software. And it looks like that it somehow like a summary of what we heard now here in this here in this session in all the different presentations. And I will start my presentation with providing an overview showing some of the well-known success stories of open source. So Linux, the operating system, Eclipse, the development environment, and Kubernetes, the de facto standard for the de facto standard tool for deploying some containers into the cloud. So they all are managed by some foundations. They have their licenses. In this case, they all have some different licenses. And they are very impressive with regard to their sizes. If we look, for example, at Linux, so they are the current stable version, more than 30 million lines of code, around 2,000 developers are contributing per year, and it's also very, very dynamic. So there are around 1,000 changes per day. So really impressive and successful projects. If you look again at Linux, 90% of the public cloud workloads are running under Linux, or Kubernetes is almost used by all public cloud providers as a tool. So if we go to the next slide, then I can add some more high-level numbers. That adds what Knut just said. To keep it short, I will just mention the last two boxes related to the number of developers. So according to a report from GitHub, currently today there are around more than 50 million developers contributing to some open source projects on GitHub. And there is a forecast that this number will raise up to 100 million by 2025. And in this forecast, it is also said that the share of US-based developers will be around 16%, followed by China with around 13%, and finally India with almost 8%. In this forecast, Europe or some European countries are not mentioned. If we want now really to understand what, I mean, at this high level, open source is definitely looks very, very successful, and is definitely can be considered as an engine for innovation. But in order to really understand the full spectrum of open source, we need to go a level deeper, and that is what NESI did and what is described on the next slide. And we discussed in our position papers the multiple facets and the different views that you can have on open source software. And one of these important aspects is, of course, the costs. Usually, as you know, there are no license and maintenance costs for open source software, but there are some indirect costs. So, for example, if a company want to reuse a piece of open source software and want to integrate it into their solution and products, then of course they need to have the know-how how to do it, the experts to do it, and you need to know the technology behind, like container technology. Or if you want to modify and adapt the open source software, which you really can because you have the access to the source code, then again you need the experts and the skills to understand the software, and you need to have the programming skills to do so. And in some cases it might also be a bit problematic, and then the company could face some challenges if the modifications that the company is doing on this open source is not flowing back into the community code, and then you have always the problems with the upgrade. User engagement was another aspect discussed in NESI. Here open source is very good, is doing very well, especially for some open source software pieces around middleware, because in this case the developer developing this middleware are often also the users. Also already mentioned here in our session, open source also allows to develop actual skills, programming skills, and so on. And open source is also in the meanwhile a part of a marketing strategy and a marketing argument. Communities, that is really the key of open source, and for a successful open source software project you need to have an active community that is active over a longer time. You need usually also be aligned very well with some industry interests. The project need to be well timed, and the project should also have a good governance. Otherwise, it's a little bit questionable whether this open source software will be maintained over time and will be of good quality. Often it is said, and it was mentioned also in our session, that open source helps to avoid lock-in to some specific vendors. But, I mean, that is true. But on the other side, at the end, you rely on the community of the open source community, and perhaps also on some service providers providing the missing skills that a company need in order to deal with this open source. Security is an area where people have quite different views. So on the one side, it is said that open source has a higher level of security because you have access to the source code and you have this transparency. But on the other side, we all know some vulnerabilities in open source software. So famous one is the Heartbleed, which was undetected for I think 1 or 2 years or so. And in a recent paper, is talking about some invisible Trojans in open source. So at the end, the security of open source simply depends on how well managed the open source project is and how much effort will be put by the community in securing this open source software. And the final point here, licenses. You have seen in my introduction examples that all these famous projects have different licenses. In total, there are more than 200 different open source licenses out there. And in order to use open source software, you should, of course, check this license and should understand it, how to use this open source, simply to stay on the legal side. And I think it was already mentioned by Miguel that for handling all these open source related aspects, you need to have an internal open source strategy, setting up some internal processes to check these licenses, and also to have at least some rudimentary checks for contributing to open sources. And all these internal processes, of course, also cost, and that you need to take into account in the total cost of ownership for open source. So there are these kind of very different aspects. And if we now go to the next slide, then we can conclude that there are different views on open source. There are enthusiastic supporters of open source. There are also organizations and people who are a little bit more skeptic about open source and who are even totally against it. As already mentioned, we need, if a company wants to use open source, it definitely needs a strategy, as Miguel explained. Open source has a clear positive effects, especially around innovations and also for the research community. But it is essential to have the right skills, the technical skills for reusing, adapting, and extending source code, as well as knowing about all these licenses. We also need to face the fact that nowadays the open source initiatives, and quite successful ones, are often driven by business interests and companies. And another aspect that was pointed out in the discussion with the NESI partners was that open source is of value, but also proprietary software has a value for European leadership in software. So both definitely coexist. And with regard to the digital autonomy, as already mentioned, open source software is a tool that might fit well to achieve digital autonomy, but it's not only a way, or it's not always the best way to achieve this digital autonomy. So the recommendations of NESI on the next slide, in summary, is that definitely open source should be, the open source model should be supported, continue to be supported. But on the other side, it should not preclude then other models of software licenses, like software as a service or proprietary models. And for example, a general requirement to saying that all the software created in context of a EU public funded project should be open source. It's probably not such a good idea, because it would exclude some companies and organizations from participating in those projects and contributing with their innovations. Therefore, it would be a better way really to think about, what are the topics, the areas where open source approach fits very well and fits to the European interest, and where we can create this sufficient large community to develop this open source software on certain topics, as indicated here in this some examples. So that concludes my presentation, and so back to you, Luis.
Presentation and your insights. Well, certainly I see very powerful messages on the need to continue supporting open source, which is something very interesting to be heard from an industrial organization. These kind of messages, I suppose that it would have been very difficult to reach such an agreement 20 years ago. And also, I see that there is agreement in the industry that there is a clear need for open source strategy. We have still time for some questions. I have seen that in the chat there have been many questions, and many have been resolved. So I don't know if there are still some that are still to be said, but if that is the case, then I invite you to take the step I guess Luis has fallen into a network hole. Can I be heard or not? Hello? Nobody's hearing me? Yeah, we can hear you. No, because I just say has fallen into a network hole, so I thought maybe I'm speaking to nobody. Yeah. Okay. So I will just make a quick question to Knut, actually. And well, your study has been really relevant and has been outspoken in many media. And one of the things in your study concerns, an econometric forecast that says that an increase in open source commits would induce an increase in GDP. And my question is, to what extent do you think that recognition could play a role in and the multiplying effect in this increasing the number of commits to open source? And second, how would you implement such recognition, and what are the best tools that you believe that could serve for that?
Yeah, I think the contributors get the recognition from the open source community, but maybe this could be also a little bit leveraged beyond the core kind of participants. And we know from other I think innovation supporting instruments like for example patenting. The European Patent Office kind of launches awards of the inventor of the year or the invention of the year. That has a long tradition and has also a certain visibility into the whole innovation community, and also maybe a little bit closer or similar to the open source communities. Also, Senelec has established awards of individuals who are really making major contributions or chairing important standardization committees or projects which kind of realized a successful transfer of research results into European standards. And maybe some similar European open source award is maybe also strengthening a little bit the idea of the digital autonomy of the European open source contributors.
Thank you very much, Knut. That's certainly a thing to explore and to understand to what extent it can be followed in the next work programs of the European Commission. In the chat there is also a question, and some questions concerning the kind of license. And Joseph, I would like actually to have what are your views as the industry platform, because it's being said that the general opinion, what is the views of the different partners, or at least if there is a view in general on using says liberal licenses such as the BSC, the Berkeley Software Distribution, I think it was, and the GPL, the strong copyleft licenses, because it seems to be that companies would not collaborate as soon as GPL. Is there a common view in the industry that GPL would preclude from collaboration, or to what extent the license model would affect this collaboration?
Yeah, as I mentioned in my presentation, there are so many different licenses around, more than 200 and so on. And at the end, I mean, open source software is a tool. So you really need to have differentiated view on open source, and then you need to consider for which purpose you want to have this open source software, and accordingly then you should select the right license that fits this purpose. So we already mentioned open source can also be used to set de facto standards, or in some open initiatives, open not only related to open source, but also related to open architectures and open APIs. You can use open source software as a tool to implement a reference architecture, for example, for this open architecture. So that is also another example. And depending on on the use, you need to select the proper license. So I would say there is no general statement. This one is the right one, and the other not the one.
So to a certain extent, every license could be accepted between different partners and depending on what.
Yeah, exactly. And it depends on the subject and the intention, motivation, and the the community and the main players in this community.
Okay, there is another question raised in the chat, and Mirko, actually, I think that maybe you would be the person to answer, because it said that, well, customers, users will rely on services they trust. That means that they have to be fully maintained and updated to avoid security holes. What are the business models behind open source so that it gathers companies' interest to invest in? And as founder of Endocode, I think that you're the one in position to actually explain what are the business models that actually allow companies to succeed using open source.
Yeah, so first of all, I would like to say that the Wikipedia article there is not super enlightening on that regard. There's a book coming out by Oxford University Press that has a lot more details on this and will be open access. So hopefully in the next month. The most important aspect here is to understand that there is a difference in the roles of service providers and open source developers. They can overlap both in the people that are doing it and in the organizations, but they're not necessarily the same. So for example, the open source community that develops Kubernetes is the community of those parties interested in the technical capabilities and performance of this system. A service provider that takes the system and runs a service with it is primarily interested in the stability of their products. There's an overlap in interests that makes the service providers contribute, for example, patches that they develop back to the system. But this alignment of interest is not always automatic. So for example, there's a built-in, well, almost kind of different perspective between the developers that have an interest in adding new features and the providers of services that have an interest in the stability of their environment, and they don't necessarily want things to be added, for example. And this difference in perspective sometimes culminates in these like accusations that one party is using the software without contributing. And that's, I think, not very productive. The business models need to reflect a very clear perspective of market differentiation. In the end, a business model can only be successful if consumers, on their own perspective, have an interest in acquiring services from a company. And something being open source as such is usually not of value to many consumers. Some have an interest in that. But trustworthiness or stability are actually values that are useful to consumers. So I think the key to the answer of what is a good business model is what value can you provide to consumers. And sometimes that means, again here, being open source is a tool to get, for example, contributions to enable collaboration to make one good platform. But we don't see many successful cases of people using open source software to build a differentiating business itself. So that's why we usually see differentiation between service providers and developers, or cloud services are running open source software, but they're not selling open source software, they're selling access to machines. And I think this is the first question that should be asked there is, what do I build that consumers are willing to pay for? This does open a market, for example, for professional services. This is very strong in open source. It also kind of concentrates the expertise. We have seen that there's a strong constituency here in Europe. But that's only one example of potential business models.
Well, that certainly gives another view of what how open source. 20 years ago, they were speaking about how can you make business out if you cannot sell the code. Actually, you're saying, well, it's because they differentiate. They don't really sell the code, but actually sell the service. And this is actually what was foreseen, and it seems to happen. And my question for later would be actually that. How do they say open source as adding value to their customers, and to what extent it represents avoiding a cost, and actually where is the value that they add, and to what extent open source is not to do with it, but actually to reduce the difficulty of reaching this value added to the customer.
Yeah, so in our case, we are an RTO, so a research and innovation and research and technological organization. So in our case, we focus more on innovation. So what we use is the open source as the baseline, let's say, in most cases. So for instance, we take a monitoring stack, open source monitoring that is well known. And from there, what we do is we add artificial intelligence capabilities, for instance, to detect anomalies or concept drift or whatever. So what we do is we innovate on top of that, and we add functionalities to, let's say, already static or known functionalities. So we are adding new functionalities and new research and scientific knowledge to what is currently in the market. And that's what we sell in Horizon 2020 projects, in my case, because that's my main focus, but also to our customers when we do customer projects. So that's what we do. And then we release that code in our Git repositories, in public Git repositories that we have for release as public, that we have public for as a result of our projects. Yeah. So that's what we
Thank you, Leire. I see actually that the on this thing of how to make business of open source, there is, I would say, another step in the level of abstraction on what you have just put in the chat, John, concerning IP. Instead of thinking of IP ownership, what about the IP support, IP delivery, IP services? So actually to make sure that I wouldn't say intellectual property, but I would say the technology that you purchase that continues to be valid, because here with the intellectual the capacity of property for what you have provided probably is not the thing, but actually the fact that it's a technology, it's not artifacts, but actually abilities that you are putting in, and then you actually make a business out of it. To what extent have you implemented this philosophy under your project, and specifically under the developments on HPC and the new processing architectures?
Well, I think my point was really more along the lines of demonstrating that there are successful business models, right? So Red Hat was sold for 32 billion. And in that context, it's really making value-added services on top of open source, early access to technology and delivery, and making it easier from a support side. So if we look at that in the software context, that's pretty straightforward to understand. People want a useful product, and there's value in that versus saying building Linux from scratch. On the hardware side, it's even more of a barrier because the implementation of chips is very intensive from a technology and time perspective. Probably 80% of the effort is on the implementation side versus the actual IP that's going in there. And so when you look at that, there is even more added value. It's not the idea of the chip that you want to buy, it's the actual artifact itself. So if we can move to this scenario where we get the benefit of open source and standardization, and we go from a delivery mechanism versus an ownership mechanism, this is a way to differentiate, but obviously there's other added value on top of that that you can add and give customer differentiation. So in that, it's really the specialization and those pieces that companies can go through and do that. In the research space, we want to put things in the open source so that they can be used. And from a hardware and HPC perspective, the software is easy to demonstrate, and you can do that pretty straightforward. The ideas behind the hardware take more effort. And being able to push those into a silicon artifact and demonstrate the utility of them makes it the technology transfer from research to industry and hardware much faster. And so that's one of the things we're trying to enable, providing as much open source as possible, but then also providing artifacts that demonstrate the usefulness of the research idea so that other companies can take that up and exploit them and do the technology transfer. And that's a challenge because there are, tools and other vendors that are trying to limit that process. And in hardware, there's a lot more resistance in having open source components. And so the entire stack is not conducive to course, and that's something that we need to break through and create momentum around. And myself at BSC, the folks at ETH Zurich, all these people that are pushing out RISC-V open source solutions are trying to do that, but it is somewhat swimming upstream because tool vendors don't want you to do that. EDA tools, there's limitations on the physical design side and the foundries, right? So these are all things that will improve. It's going to take time.
Well, certainly you're pointing out to the differences between hardware and software, and I remember seeing in the internet someone who had built an integrated circuit at home, but for that he needed a vacuum chamber and no matter what number of equipment. Well, I suppose that my wife would never allow me to create such a lab at home, and it was only, I would say, 700 nanometers. I think I remember something like that. But anyway, Mirko, you're also pointing to this thing, the difficulty of transferring ideas from pure software to actually hardware. And to what extent do you think that there are things that are quickly replicable in software, in hardware as happen in software, and what others could actually take a little longer or even be in the verge of science fiction? That we say, well, we get the design, the source code of how to make something, and we get that piece made at home. That certainly sounds science fiction.
Yeah. So first of all, I think we're making great progress here in terms of manufacturing methods, where if you can provide a design, I don't think it's too science fiction to say that for many even complicated goods, the capability to produce them on demand and pay for the service, basically, and the time and materials that go into that is possible. And we've seen this for small parts of medical devices already. And I don't think it's science fiction to say that in a couple of years, chip manufacturing will work this way. We already have it in parts with one-time programmable chips, for example, which is a step towards that direction. So if you consider the great strides the industry has made in that regard, I'm really hopeful that something like this can come.
Thank you very much to all of you for your contributions to this workshop, and I look forward to meeting you in presence once these COVID times are out, and we can then have a coffee, a physical coffee, not like this. Anyway, thank you, and see you at the main room now.
Sounds good. Thanks.
Thank you.
Bye-bye.
Bye.